Let's return to environmental chemistry, the techniques. Well, environmental chemistry requires mastering several sub-disciplines. Analytical chemistry, you've been doing your titrations. In second year, you've been using the atomic absorption spectroscopy, IR, NMR, all of those things. You'll be doing more of that in our course here. Thermodynamics. Thermodynamics is about the energetics of chemical reactions. It's about equilibria. It's about how things settle down, and it can settle questions such as how much of that toxin will be in the environment at the end of the day. Chemistry also involves physics, especially physics of the climate and weather. It's called radiation physics, or if you're a chemist, photochemistry. And of course, there's modern experimental and theoretical chemistry that needs to be mastered. Things like spreadsheets, or if you're doing more complicated things, programs that can calculate, for example, the climate or the weather 1, 2, 3 days in advance, 50 years in advance. It's a huge field. It's multidisciplinary. Look, the important role of the environmental chemistry as its own field was recognised a long time ago. The International Union of Pure and Applied Chemistry, IUPAC, has organised several investigations into environmental impact of pesticides for many years. And it's not an old topic, but it's one that continues to return. Let's look at the evidence for strain on Earth's physical systems and chemical systems. On the graph on the right here, you will see little panels showing global surface temperatures from the 1980s to the 2030s extrapolated on the top graph, and you can see the average influence of man in this thing. And take note of the left axis here on the temperature anomaly. It's minus 0.2 to 0.6. It's not a big deal in terms of magnitude, but it has a huge influence when these average temperatures slowly increase. And these are data from Lean Geophysics Research Letters 2009. Recent data, careful data. These are not opinions. So, temperatures increasing. As a result, we have glaciers melting. Here we have, on the right panel, pictures of the Antarctic ice shelf made by satellite altimetry measurements. And you can see that it measures the decrease in the height of the ice shelf, blue meaning quite high, and green, red decreasing, and you can see the areas on the Ross ice shelf decreasing over time in a period of 5 years. The polar ice caps are melting. Here's another measurement which may be interesting to you. As you know, Australia is very interested in mining, and one of the techniques that people use in detecting ore bodies is measuring the differing gravitational fields around the Earth. So as a result, there are satellites that measure the change in gravity as they move across the surface of the Earth. And they've been used to detect the loss of ice in the polar regions. And this is one of the graphs shown here. You can see the ice loss on the tip of South America, a lot of ice loss here in Alaska, and up here in the North Pole. What's causing all of this? Look, I haven't mentioned even CO2. I'm not going to bother about that. You're all aware of that. So we'll be going into detail on that topic later on. What's causing all of this? Yes, chemicals, but behind the chemicals is the humans, the human population. Don't forget that. Here's the graph of the human population in kilo years. 0 represents the current time. This is 10 to the minus 5, and this is 100 years hence. This is a logarithmic scale. And you can see the population is increasing exponentially. That's a problem. But what is the source of the problem? it's not just humans, it's the humans demanding energy. Energy is the key. Why? Because energy is central to extracting resources, building materials, medicines, health, transport, growing. Just the act of growing things requires a huge amount of energy through the production of fertilizer. Without fertilizer, we would not be able to sustain the current populations that we have now. And now things are becoming critical. The old ways can't be sustained. Let's take a brief look at the effect of human population on the human support systems. Previously, we were considering the effect on the environment and the chemistry. This is a results from paper by Grantham 2012. Consider these facts. Before 2002, commodity prices generally declined by 70%, but after 2002, prices have tripled in 6 years. That's evidence of exponential growth. Growth in the population, in the production of grains, has fallen to 1.2%, which is exactly the growth rate of the population. That should be raising alarm bells. Shortage of fertilizers, phosphorus, which you all know superphosphate. It's a major product used in productions of grains. That comes from phosphate, either from bird poo from Nauru, but that's now exhausted, so they're going to deep deposits of phosphorus and potash. They can be found in Canada and Morocco and Russia. So there are just a few countries with huge deposits, and that creates tension, political tension, human factors. So consider these things. These are the human factors behind the course, and I wanted to put these factors into perspective so that you can think about them and see how the techniques that you're learning in this course apply to those outcomes. See you later.